The next topic is uniform motion. When a moving body covers equal distance in equal interval of time, then its motion is known as uniform motion. It means if any consider you are driving bike or cycle and you travels first 1 kilometer in 1 hour, and next 1 kilometer in 1 hour, and next 1 kilometer 1 hour. It means per hour the distance traveled by you is the 1 kilometer. Then the motion of you then you it means your motion is uniform motion. And we take an example from data. Distance x in meter and time 10 second. We take a time 0, distance is 0, time 1 second, distance is 1 meter, and time is 2 second, distance is 2 meter, time is 3 second, distance is 3 meter, and time is 4 second, 4 meter at 5 second, 5 meter, and 6 second, 6 meter. Okay, we have to first point, we can decide clearly by getting this data the interval of time. It means 1 second, this is the 2 minus 1 1 2 minus 1 1 second, 3 minus 2 1 second, 4 minus 3 1 second, 5 minus 4 1 second, 6 minus 5 1 second. The interval of time is same for all things and all the cases, and the distance traveled by the body is 1 minus 0 is equal to 1, 2 minus 1 is equal to 1, 3 minus 1, 3 minus 2 is equal to 1, 4 minus 3 is equal to 1. It means the traveled by the body it's same for same interval of time. So if we represent this data on the graph, we take x-axis and y-axis, and this is the 1 second, 2 second, 3 second, 4 second, and this is the 1 meter, 2 meter, 3 meter, and 4 meter. Okay, and then for 1 second distance is 1 meter, for time 2 second distance is 2 meter, and time 3 second distance 3 meter, and so on. So we get a point of intersection. This is the 1 and 1 second and 1 meter. There are point of intersection. By joining all the point of intersection, we get a line, straight line. This is the straight line. Okay, in this case this is the straight line, and for the other case maybe curve. Okay, so this is the line, and this is the angle. Okay, between x-axis and this slope. So this is the altitude, this is the angle, this is the base, this is the hypotenuse. Okay, then this graph, this slope is the straight line. Then by getting this straight line, we can say that the motion is uniform motion. It means the point should be noted that for any straight line on the graph between distance and time, the motion will be uniform motion. And the next term is non-uniform motion. If a moving body covers unequal distance in equal interval of time, then its motion is known as the non-uniform motion. It means there are two cases, that first time of interval may be same but distance will be different, or the distance may be same and but interval of time should be different. It means in the distance and time, one quantity will be same or other will be different. Okay, for example, we take in some data. X is in meter, time in second. For 0 second, time distance is 0 meter. For time 1 second, the distance is 1 meter. Time is 2 second, distance is 3 meter. It means you observe here, 0 for 0, 1 for 1, but the ratio here for uniform motion 2 for 2, 3 for 3, 4 for 4, 5 for 5, but here 1 for 1 but 2 for 3, okay, and 3 for 6, 4 for 10. It means the interval of time is 1 hour, distance traveled by the object is 1 meter, and interval of time 1 hour, the distance 2 minus 1 3 meter. For one next one second, 3 minus 2 is equal to 1, 6 minus 3 meter. So it means I wants to clear you that there is a different travel distance for the same interval of time. In this case, we will describe this data on the graph for 0 0 0 to 0, and for 1 second distance is 1 meter, 2 second is distance 3 meter, for time 3 second distance is 6 meter, and similarly for 4 second there was a 10 meter. So if we join all the point of intersection, this is the point of intersection by 1 by 1, 2 by 3, this is the point of intersection. By joining all the point of intersection we get a curve. So the point should be noted that if any line is curved, if any curved line on the graph plotted between distance, and this is the distance, along the distance, and this is the time along the graph is plotted between distance and time, and that line is curved, then the motion will be non-uniform motion. Okay, this is very important. I think you should do more work, more exercise on this topic, because this is the very important, and this is the very useful topic for all the subjects, where whenever you wants to plot the graph, this concept will be useful. So in any other video we will describe about the how can we plot the graph between different quantities. That will be a special video for graph, but here for uniform motion and non-uniform motion, this will be the graph. And if there is a point, should be noted that the per second the distance is increasing, so graph is this, along this, okay. But if the distance is decreasing, consider 10, there was 10 and 6 3 0, it means if the distance traveled by the object is decreasing, this is all about perfect. We will describe the other video, okay.